All right, so let's take a look at this. Here. They will, you're right. Need a reader for 10 points. This is our big idea. You got it up on your screen. It's 10. It's easy if you see it from your screen, right? Huh? She's got to read, but then there's something else to read after she reads. So I'm assuming you're going to read. You got it. The agenda, yeah, it's in these words.
No, it's not. Students will be able to mathematically calculate for average angular velocity with respect to change in angle theta, as well as the change in time. Theta and
Tori. Don't feel bad. Cole used to triple.
I still mess up on a lot of them words.
You're going to be next. So this is what I'm saying. You can access this here. You can read, but we do next.
I'll still let you pull it up like that.
What did you do? So she's gonna read it to us. I'm gonna go to this next page. This lady here is gonna read it. That's for I think another 10.
That's what she could read.
Antique long plan phonograph record rotates clockwise at 77.65 revolutions per minute. What it is, and angular velocity and radians per second.
Okay.
Can see page 270.
Thank you. And then that's the book page number. So I'm gonna crack that book open and get to 270. I'm about to give you your first part of your
I'm
notes.
gonna show you where your points go. Or do you know?
Samir, you sitting next to a powerhouse back there.
You got 20 for more.
I think you had a high A, didn't you, Jones?
Well, my points
Okay, so let's delve into it. What do you need to do this problem? First part of your notes is going to be right here. Right?
So you got about 40 points. But if you're not saying don't forget.
So I'm just showing everybody what you're supposed to be typing out first. The new section. Once at the top 270, there's this box here that describes what you're going to talk about. And then there's your problem. So this box, everything in that box, type it in, including the symbols. Okay?
Type this in.
Is there a bathroom available?
Everything in the box. That goes in the weed section.
Oh, wait a minute. Why is it?
So you scroll down to the weed section, go back to your document. I mean, something wrong. Oh, you dragged the cat up.
And then, like, you got to, sometimes you do the things, I don't know where you got to, like, read some slides or man, you were just, I'm like, what is he doing?
Alright, if you need help finding the symbols, you just go to your insert character thing. So let me start writing it out, and then we're going to talk about this problem a little bit. So as I stated before, we talk about robotics, especially cars, just motors, generators. There's rotations. And the first one we're going to discuss is average angular velocity. So this is known as average angular velocity. Okay? And its definition as an equation is omega. That's not W, ladies and gentlemen. If you need help with these symbols, remember, this is not W. It's the Greek letter known as omega. I'm trying to write it. I can't write it. I'm too much rest over spring break. So omega subscript AV is equivalent to delta theta, right, divided by delta t. So if you need that, what's wrong? Are you trying to do the change?
Me.
Okay, you good to go.
I'm coming in. That's how do you do this?
What's his name?
Christian.
Oh, I know
Lopez.
Christian Lopez. Yeah. Oh, you got a laptop? Thank you, Jonah. Harris did talk to you, right, Jonah? Okay. So you know what you got to do. What was that? So let's explain what all these are, right? And you have this first part of your notes covered if you just simply type what's in that box. You know, right, pointing the arrows and everything like I'm doing. I'm just explaining a little bit more because, you know, that little box doesn't explain everything as far as what is each of these measured in. Again, this is not 0 right here. This is called theta. All right, also known as the angle that's given in your problem. These triangles, they're called delta. They're not, you know, regular alphabet letters. They're Greek letters. This is delta. And both of these are delta, by the way. This one here is not W, it's called omega. Okay? Now, what are they measured in? Well, if we talk about time, right, it's always measured in seconds, or depending upon what measurement they give you in the problem. We're talking about theta, well, that's the angle. It can be measured in two flavors. One is radians, or rads per second, which means rads is a short way of saying radians. Or you can measure it in revolutions per minute, or RPM. I know you've seen RPMs when you're driving your car, some of you always driving. You see the dial go up, that's what RPM means. When it comes to this here, you simply are looking for whether or not, and I did this wrong, this goes here actually. Because this is degrees, right, or rads, that's what I'm trying to do. So rads per second goes here, or RPM, or rad per minute. There we go. And this is supposed to be degrees that you can measure this in, or radians. That's better. Okay? Again, you don't have to do everything I did here. You just need to have everything in that box typed out. And this will be covered, your first part of your notes. Let's box this off. And again, it's part one of your notes. If you're trying to keep your notes in order. But all you gotta do is type what's in that box, and you got this part. You'll type what's in that box. This is covered. You got the box, symbols and all. Okay. You need help finding these symbols? Yes, you have to type them. Let me know. No. Part two of your notes. Let's get the ingredients on how we're going to solve for this problem. I know. And these are elements you're pulling straight from the problem that they gave you. So we start off with the problem. Where's it on my paper? I got a paper copy? I do. So, all right, looking at this, it says the antique long player, right, LP phonograph record rotates clockwise, right, at 77.65, right? Now, think about it. If we're going clockwise, right, we're going this way. If we're going counter, we're going this way, right? Think about clockwise. So, with that said, there's going to be a negative value that we're using. And we got to do something called dimensional analysis. I'm not sure if y'all had me for physics, but dimensional analysis is where you pretty much convert your age from years to seconds, or you go from pounds to, what's wrong? You frowning up, what's wrong? You, is everything all right? Oh, okay. So I was like, what's wrong? All right. Maybe lose track of what I said. So we're going to put omega AV, right? Because that's what they're giving us. This is our angular velocity. They gave us a speed. I don't know if you know what an LP is or long phone is. That's when you was playing records on vinyl, right, back in the day. Now y'all have CDs and download streams. It is what it is. So we'll say omega AV is equal to a negative, right? I told you it's going clockwise. And we're going to need to write down what they gave us, which is 77.65 RPM means revolution per minute. Keep that in mind. So 77.65, and then we put RPM for revolutions per minute. Okay, that's how you write that shorthand. Next, we need some standard conversions. Okay, because the problem is saying, hey, instead of revolutions per minute, how do we get it in radians per second? So we got to go from minutes to seconds. How many seconds are in a minute? Anybody know for 5? Yeah, raise your hand. Who said that? You? 60, right. Okay, give yourself 5 extra. So, you just put a star here, y'all. This is something you should know as a standard conversion, right? The problem didn't give it to you. So, like Samir said, in 1 minute, so we know, we converted, we know there is, because it's equivalent to 60 seconds. Okay? How about our other standard conversion? That one you might not know, but I'm going to go ahead and tell you what it is. Well, in 1 revolution, right, so we put a star here because this is a standard conversion. It's not a given. So in 1 ReV, revolution, excuse me, we have an equivalent of 2 pi rads. Again, pi is a Greek letter, so y'all can look that up. It's spelled P-I, by the way. It looks like this. It's not P-I-E. So what are we trying to achieve here? Well, we want to convert, at the end of it all, our angular velocity, average angular velocity, omega AV, not W, y'all, into some number that you're going to figure out, but it's going to be, instead of RPMs, it's going to be rads per second. Okay? So, yes, ma'am. So let me box this off. This is going to be part 2 of your notes. These are all the ingredients you're going to use to solve our problem. So right after you get the notes for your box on that page 760, I think, you're going to type this, or 270, I'm sorry. You're going to type this in. Try to type it the same way so it makes sense to anybody that's reading your work. This is part 2 of your notes. Part 3. Now here's where we're going to do some serious math. Where can I fit this at? I'm going to say, hey, number 3 of your notes. It will say step 1. It's a lot of steps. This is one big problem. Huh?
Did you print out the paper copy?
I did. Why was wrong?
So I could do it.
Oh, yeah, of course. Listen, we're going to solve. This is going to state our case, our margin orders, for omega AV, right? In, what do we say? Rads per second, okay? So, let's go ahead and do that. That'll be omega AV is equal to, anytime you want to convert something, you simply just turn it into a fraction. So the first part is 77, or negative. And that's what? Rev per minute. So revolutions per minute means this when you turn it to a fraction. We'll continue on. We're going to multiply it because now we're going to cancel out some things. It's a different color here. So we got to cancel out revolutions. That's the first part, right? And then we got to go back and fix our seconds. So we're going to start with the equivalency for a revolution. 1 rev is equivalent to 2 pi rads. So let's put it together. We want revs to cancel, so we'll put it in the bottom. So 1 rev is equivalent to, let's put it up top, because we can cancel our revs now. It's equivalent to 2 pi rads. What's wrong? So now if you're paying attention, you can cancel out revs, or revolutions. because revolution divided by revolution is 1. It's like A divided by A is 1. So I can cross this one out and that one. And then I got one more conversion to do, because remember, we don't want it in minutes, RPMs, we want it in seconds, rads per second. So we got rads now, but we need to cancel out our minutes. We can use what Mr. Marks gave us, which is a standard conversion you should know. So that was, for every minute, you have how many seconds? 60, right? So we can cancel out minutes now. I can rewrite this in a way that we can just calculate it out and be done with it. So that'll become, like we said, this is a step, this is a step. So we have omega AV is equivalent to negative, because of how it's rotated. This is pretty much a vinyl or a disc or a record player. So negative, and then what goes up top? Well, you don't put what's canceled out in there anymore, right? So it's going to be 77.65 multiplied by 2 times pi times, and then I'm going to leave rads on the end of it. In the bottom, we have this gone, it's just 60 down there. And the ratio in measurement is now just, like we said, rads per is the line here, and then seconds on the bottom. That's how you write that instead of shorthand, mathematically. Calculate. And it comes to negative. Grab a calculator here. With these calculators, you gotta be careful. If you're doing radians, right, then you'll have your calculator in radians. If you do rads, it's radians. If you're doing degrees, well, that means you're gonna be in revolutions. So just check your calculator and be sure. We're gonna turn this bad boy into, make sure it's in degrees. And this is in degrees. I can show you how to do it if you want. So I type it in, use my calculator feature. I'm sorry, my fraction feature, menu, this button here, turn that. I'm in your way, sorry. And it'll be 77.65 times 2, here's the pi button, and then we're going to divide it by 60.
What if you have got no space for 3?
For 3? We need space.
You said we're taking all this out, right?
It's just gonna automatically go there.
Yeah. I look like you in digital land. It's just going to keep going down.
Yeah.
That's why I didn't like the paper thing. Give y'all a lot of room. Plus it autosaves, so you don't have to worry about losing your notes. So the answer at the end of it all is negative, because when I was rotating, 8.13. So we write that out. And of course, our what is measured in is rads per second.